Welcome to Cosmic Curiosity Lab, a place where we explore the universe not through speculation, but through evidence, wonder, and the deep connections hidden in nature. Sometimes, the story of space begins with a telescope, sometimes with a spacecraft, but sometimes it begins with something much smaller: a fossil, a coral, a tiny record of ancient life buried in stone, quietly preserving the rhythm of a planet. And today, we are going to follow that record all the way from the ocean floor to the moon. Because the moon, as still and silent as it looks in the night sky, is not actually standing still. Every year, while we live our lives, the moon moves a little farther away from Earth. Not much, only about 3 to 4 centimeters per year. Roughly the same distance your fingernails might grow in a year. It sounds tiny, almost meaningless, but if we rewind time by hundreds of millions of years, that tiny movement becomes part of a much larger story, one in which the moon was once closer to Earth, a story in which the moon was not always where it is today. Long ago, the moon was closer to Earth, and one of the strangest clues to that ancient relationship was not found by a telescope. It was not discovered by a spacecraft. It was not even found on the surface of the moon. It was found in the ocean, inside the skeleton of a coral. Corals are not just beautiful structures in tropical seas. They are living organisms that build skeletons layer by layer, rhythm by rhythm. In some corals, such as Acropora palmata, scientists can see annual growth bands, a little like the rings of a tree, but formed under the sea. But when researchers looked more closely, they found something even more interesting. Inside those annual bands were much finer lines, tiny, delicate marks. And the idea was simple but brilliant. What if those fine lines represented daily growth? One line, one day. If that was true, then the coral was not only recording its own life, it was keeping a calendar of the ocean, a calendar of Earth. Now comes the beautiful part. The American geologist John W. Wells studied fossil corals from the Middle Devonian period, around 350 million years ago. This was long before the dinosaurs. On land, complex plants were only beginning to spread. In the oceans, there were ancient reefs, armored fish, trilobites, and strange creatures that seem almost alien to us today. But inside those fossil corals, something had been preserved: the rhythm of ancient days. When scientists counted the fine daily lines inside one yearly growth band, they did not find around 365 lines. They found roughly 400. That means that, at that time, 1 year had about 400 days. But not because Earth was taking longer to orbit the Sun. A year was still roughly a year. The difference was the length of the day. The day was shorter. Earth was spinning faster. Instead of 24 hours, a day was closer to 22 hours long. And suddenly, inside the fossil of a small marine organism, scientists had found a record of the rotation of an entire planet. But how do we get from coral to the moon? The answer is tides. The moon's gravity pulls on Earth's oceans, creating tides. Not simply as two neat bulges of water, but as part of a complex gravitational dance between Earth, the oceans, and the moon. As Earth rotates, the oceans move. Friction acts. Energy is slowly transferred, and the result is an incredibly slow process. Earth's rotation is gradually slowing down. The days are becoming longer. But in physics, that energy does not simply disappear. As Earth loses some of its rotational energy, the moon gains orbital energy. And because of that, the moon slowly moves farther away. So if days were shorter in the past, Earth must have been spinning faster. And if Earth was spinning faster, the moon must have been closer. The coral never saw the moon, but it recorded the consequences of the moon's gravity. Today, we do not have to rely only on fossils. During the Apollo missions, astronauts placed special retroreflectors on the surface of the Moon. They are mirrors designed to reflect laser light back toward Earth. From observatories on Earth, scientists send laser pulses toward the Moon. The light travels across space, hits the reflector, and returns home. By measuring how long that round trip takes, scientists can calculate the Moon's distance with incredible precision. And the result is clear. The Moon is moving away from Earth by about 3.8 centimeters per year. That is slow, almost impossibly slow. But the universe is very good at slow processes, because when you have enough time, centimeters become thousands of kilometers. And ancient corals tell us that this process has been happening for a very, very long time. This story is more than just a scientific curiosity. It shows us something profound about science. Sometimes, the answer to an astronomical question is not found only by looking up at the sky. Sometimes, it is found in stone, in ice, in tree rings, in ocean sediments, or in the skeleton of a coral that lived hundreds of millions of years before us. This is the kind of connection Carl Sagan often loved to point out. The idea that the branches of science are connected much more deeply than they first appear. Biology can speak about astronomy. Geology can speak about time. The ocean can speak about the Moon. And one fossil can tell us that the sky above ancient Earth did not look exactly like the sky we see today. The Moon was a little larger in the sky. The days were shorter. The tides may have been stronger. And our planet had a different rhythm. So the next time you look at the Moon, remember this. It is not completely still. It is not just a silent, glowing sphere hanging above us. It is part of a system that is changing, slowly, quietly, year after year. And somewhere deep in the fossils of ancient seas, life left a trace of that motion. A coral grew day by day. It knew nothing of Earth's rotation, nothing of gravity, nothing of the Moon. And yet, inside its skeleton, it recorded the rhythm of a planet. Hundreds of millions of years later, we learned how to read that record. Maybe that is one of the most beautiful things about science. The universe does not always leave its answers where we expect them. Sometimes evidence about the Moon is hidden in stone, that was once alive. If you enjoy stories like this, where life, Earth, and the cosmos connect into one bigger picture, subscribe to Cosmic Curiosity Lab. Because sometimes, to understand the sky, we have to look carefully at the traces life left beneath the sea.